Welcome to this video on AutoSys AWS Step Functions solution. In this video, we will explain the AWS Step Functions integration with AutoSys and what it brings to the AutoSys user community. AWS Step Functions is a powerful serverless orchestration service that seamlessly integrates with various AWS functions, third-party systems, and APIs to build business-critical applications. Integrating AutoSys with AWS Step Functions allows you to start and restart state machines within AWS Step Functions directly from AutoSys. We'll provide some technical insights so that the integration components are clearly identified and the deployment sequence is understood. We'll focus on the design and execution sequence of an AWS Step Functions trigger start execution job. Finally, we'll run through a demo. AutoSys plays a central role in orchestrating operations across multiple environments, including the cloud, and synchronizing these processes with other non-cloud operations. Integrating AWS Step Functions allows us to centrally configure process automation in AutoSys. Subsequently, we can start, monitor, restart, and supervise all processes from a single interface. These AWS Step Functions processes seamlessly sync with different environments supported by AutoSys, such as applications and databases. This integration allows you to effortlessly execute and monitor AWS Step Function jobs through AutoSys. By leveraging AutoSys' advanced capabilities, you can accelerate your digital transformation efforts with greater success. Simply define your AWS Step Function jobs and let AutoSys manage the scheduling of these workflows seamlessly. AutoSys lets us build configurations with intuitive interfaces and monitor them through simple dashboard tools specifically designed for operational use. Statuses are clearly indicated, and accessing logs is as simple as clicking a button. From an operations perspective, AutoSys greatly simplifies the configuration and orchestration of AWS Step Function jobs. Externalizing operations to a tool with a high degree of third-party integration means we can synchronize all cloud with non-cloud workloads. Using various agents and job object types, we can build sophisticated configurations involving multiple applications, database packages, system processes like backups and data consolidation, file transfers, web services, and other on-premise workloads. The job submission sequence is fairly simple because all job definition properties are stored in the AutoSys plain old Java, or POJO job. All the target system properties, including the endpoint, start job REST API, access key secret, region, and other parameters, are defined in the J2EE parameters. These parameters may vary depending on the authentication method used. Let's look at the sequence of execution. We start with the three main components: the AutoSys scheduler, the system agent, and the AWS Step Functions server. The AutoSys scheduler submits the POJO job to the system agent. The system agent acknowledges the job from the scheduler and initiates communication with the AWS Step Functions server. Authentication is then initiated, with the system agent posting either basic authentication or EC2 profile instance, external provider, SAML, or assume role, depending on the specifications provided in the authentication J2EE properties. In this video, we are using basic authentication using a proxy, which uses a combination of an access key and an access key secret. AutoSys allows connections via proxy, providing additional flexibility and security in accessing AWS Step Functions resources. Once authenticated, the agent submits the job to the AWS Step Functions server as a POST request. The AWS Step Functions server identifies the matching job and executes it. The job execution returns a JSON response which contains the execution details. Both the AWS Step Functions server and system agent then monitor the job until it reaches its final state. During the execution, if a task fails within an AWS Step Function state machine, you can redrive or restart the task execution from that specific state within the state machine. Once the final state is obtained from AWS Step Functions, the job status in AutoSys is updated accordingly as either canceled, succeeded, or failed. Let's look at how to deploy the integration. First, ensure the Application Services plugin is installed as a prerequisite. The Application Services plugin and POJO extension have the CFG extension. In older agent versions, you might encounter a PAK file instead. Next, download the plugin extension package from the marketplace. This package contains all the necessary elements. Unzip the package and extract the content into a temporary folder. Navigate to System Agent Install Directory. Next, we must stop the system agent with the cyb agent-s command. Install the plugin extension with the command plugin installer, system agent install directory/path to CFG file. Now, restart the system agent with the cyb agent-a command. Remember, this integration uses AWS Step Functions public REST API. In our demo, we will create an AWS Step Functions POJO job in AutoSys. First, let's establish communication with the AWS Step Functions server. After communication is established, we can execute and supervise the job. Let's dive into the world of applications and job execution within the AWS Step Functions environment. Let's start with the demo. This is the AWS Step Functions console. Here, you can find a list of state machines available in our environment. A state machine is essentially a workflow consisting of event-driven steps, with each step being referred to as a state. These states can be task states, representing units of work that may involve AWS services such as Lambda or third-party APIs. In our environment, we have multiple state machines. Let's take a closer look at one of them. Here is the definition of this particular state machine. Pay close attention to fields like the ARN, which serves as the machine's unique identifier and is crucial for starting execution on the AutoSys side. Let's explore the details of execution in state machines. For example, we have a state machine with multiple executions. By diving into the details, we can view the execution status and the name of each execution. Let's take a closer look at one of these executions and examine its status and unique execution ARN. The details also offer a visual representation of the state machine, showcasing the various steps involved in the execution process. By opening the execution input, we can gain insights into the execution's initial input and delve into the detailed execution output. Let's return to the transaction process page, where we will walk through an example of this state machine's implementation and flow. This process involves a start and two branches, each offering two possible choices on how to proceed and which Lambda function to invoke. By navigating to the left pane, we can pull and add multiple services to the state machine. AWS Step Functions empowers us to build processes using code as long as we are familiar with the correct nomenclature. Returning to the executions, let's explore our example where we have selected the purchase branch, triggering the corresponding Lambda function before the execution concludes. For enhanced analysis, we can activate the X-ray tracing option, which logs all traces for detailed examination. Remember, the execution ARN is crucial for tracking the execution details. Next, let's proceed to log in to AutoSys. Click the Quick View tab to view the job definition. Select the job to open the job definition. The job employs basic authentication using a proxy for the demo. When the job is open, click the Quick Edit button to view the required parameter. The first step in executing a job is to select the machine on which the job is to be executed. The first parameter is the class name, which is AWS Step Functions, and the second is the method name, which is the start execution job. Now look at the gateway parameters. The endpoint parameter indicates where the AWS Step Functions service resides. Then the access key and the access key secret. Access key is the identifier and the access key secret is the corresponding secret password. The region parameter indicates the geographical region where AWS Step Functions computing jobs will be executed. The payload parameter specifies any additional JSON data that should be included with the request. If there is no additional data, this parameter can be left blank. Then we have proxy parameters. The proxy hostname specifies the hostname or IP address of the proxy server to which the connection is established. The proxy port indicates the port number the proxy server uses for communication. The proxy username is required for authentication with the proxy server. The proxy password is the password associated with the username for authenticating with the proxy server. The log level parameter specifies the level of detail for logging information related to job execution within AWS Step Functions. The sleep interval parameter specifies the duration of time the system agent should wait before querying the AWS Step Functions API again to obtain the job status. In the event of a brief downtime experienced by the AWS Step Function service, the failure interval parameter comes into play. This parameter specifies the amount of time in seconds before failing the job due to API failure. Once you have specified all the J2EE and other parameters, click Commit and close it. That completes the job definition. Let's now start the job. Once all the parameters are defined, select Start the job and click Go. To confirm the job execution, click Yes when prompted. Notice that the current run number for the job is 5015. Upon refreshing, a new execution is triggered, increasing the run number from 5015 to 5022. A status of success indicates that the last execution was completed successfully. To access the spool files, simply scroll down on the user interface until you locate the spool files section. From there, select the desired file and click on the Go button. You will then be prompted to specify the number of lines you wish to display. Reports for all statuses are accessible for further investigation or utilization. As we examine the successful job, we can see that all parameters passed by the user, such as job details and authentication parameters, are displayed. And that's a wrap for the demo on how AutoSys can integrate with AWS Step Functions to execute and monitor various jobs. Thank you for watching this video.